Hi there, welcome back to the channel. I'm the GCSE Science teacher, and in today's lesson, we'll be learning about specific heat capacity for GCSE physics. Content covered today includes definitions, calculations, and the required practical. So let's get started. First of all, what is specific heat capacity? Well, it is the amount of energy required to raise the temperature of a 1 kilogram amount of substance by 1 degree Celsius. And I've shown this visually as well. If we had, say, 50 joules of thermal energy, needed to heat up a 1 kilogram block of ice to 1 degree Celsius, it begins to melt. That is a visual representation of specific heat capacity. But I can understand why some students might think, why is this even important, miss? Why are we learning about this? Where is this going to help me in everyday life? Well, actually, it already is currently, because if you look at any electronic device you have, if you look at any time you cook anything using a stove and pan, all the evidence and research from specific heat capacity has gone into it by looking at the properties of materials and various objects to ensure that we know how long it takes for them to heat up, how long it takes for them to cool down, and therefore the safety aspect and the longevity of these objects. So it's a very useful bit of science that we are learning about today. Let's look at what you need to know specifically, though, for GCSE, not just the definition, but also the equation. So you're given this in the exam, it's in the physics equation sheet. It's worth looking at in detail, especially in terms of knowing how to rearrange it, but also what each of the symbols mean. So we have delta, which is a triangle symbol here. It's actually a Greek letter. In this case, in science, it actually just means a change in. So delta E is a change in thermal energy, and that's measured in joules. This is equal to the mass in kilograms times by the specific heat capacity, which is given the symbol C. It also is given a set of units which look quite complicated, but trust me, they're really not. It's just joules per kilogram degrees Celsius. And that just kind of shows you that specific heat capacity is all to do with energy, an amount of substance in kilograms, and it's all to do with temperature change in degrees Celsius. So that makes quite a bit of sense. And this is also times by the change in theta. This is a different symbol that you might not have seen before. This is another Greek letter. It just means temperature in this case. So delta, or change in temperature. And that's measured in degrees Celsius. Now, you can use the triangle to rearrange the equation if you need to. A lot of the time, you'll need to work out the specific heat capacity, which you can do. One of the things I would say is, because this equation is a simple multiplication equation that you see, it's not too difficult to rearrange with the triangle. However, more complicated equations do require extra steps. So just be aware of that. Don't rely on triangles too much, especially as the equations get more complicated. Let's do an example then. So 2.41 times 10 to the power of 3 joules of heat energy is applied to a 30 kilogram mass of metal to cause a temperature change of 14 degrees Celsius. So calculate the specific heat capacity in this case. So the first thing I always say to my students is, if you write it in a calculator, you've got to write it on paper too. That's so you can evidence your working out, and you can evidence that you actually know what you're doing. That's part of being a scientist, is actually providing evidence for your thought process. Something else to mention as well, when you get a question like this, you want to highlight, underline, or circle any bit of data that you're given, so you know what is actually being asked and what is being given to you. So you've got the energy, you've got the kilograms, you've got the mass, and you've got the temperature. So once you've got all that, you can then put it into the equation. I've just written out the equation I get in the exam, but then I've also rearranged it. So C is the subject. I then put my numbers in. So I've put brackets around the change in energy. And the reason for that is because if I write this into my calculator, a lot of the time the calculator will read it in a literal sense. So if you're struggling with calculations, you might want to use the fraction button. That way you can separate your numerator from your denominator, but it's worth also putting brackets in, especially when you have standard form like this. I've then got my answer, which you can see below, and I've also as well made sure I've underlined my answer, and I have my units as well, so I know that it's clear for the examiner to see. Let's have a go one for yourself. You can see the question is 4.11 times 10 to the power of 2 joules of heat energy is applied to a 16 kilogram mass of liquid to cause a temperature change of 12 degrees Celsius. Calculate the specific heat capacity of the liquid. Please have a go below. Don't forget to show your working out and units. I'd love to see how you do. Comment below, and yeah, have a good go. Best of luck. So the required practical. This is the next step. This is a quite a straightforward practical, if I'm honest. It's quite an unusual one because there's a few steps, but a lot of it is to do with math. So you have to use the equations. There's other equations you need to use as well, and you can kind of figure this out based on the equipment you'll need. But we'll run through it now. Just something to note as well: required practicals can be anywhere from 10 to 15, sometimes even 20% of the exam. So it's worth knowing the method, the safety precautions, how to apply your results or given data to the situation. You also, if you're doing triple science, you may even be asked on things to do with like troubleshooting and how to solve an issue with the practical. So it's worth knowing the method really well. So, the purpose of this practical essentially is to investigate and determine the specific heat capacity of one or more materials. So we have a 1 kilogram block. Um, we have insulated the block because we're going to heat up this block with an immersion heater. An immersion heater is one that you plug into an electrical source. We are going to measure the temperature using a thermometer. We can actually calculate the energy required to do this using the voltage and the current and the time, which is going to link to an equation that we also get given in the exam. So let's go through the method. Number one, we need to place the immersion heater into the hole of the metal block. Number two, we place the thermometer into the block using 2 drops of oil. We do the oil drop, by the way, just so that as the metal block heats up, the thermometer can actually pick up the readings easier. Because if you imagine you've got a thermometer in a metal block that has a hole in it, that thermometer is not going to be flush against the metal block. You need a bit of oil just to ensure that the thermometer is picking up the readings correctly. You then want to fully insulate the block with something like cotton wool. Number four, you record the temperature of the block, and this is the initial temperature. Put that in a table. Number five, connect the heater to the power block and turn it off after 10 minutes. Number six, after 10 minutes, the temperature will rise even though the heater has been turned off, and it will begin to cool down. Number seven, record the highest temperature that it reaches, and this is your final temperature. You then want to, in number eight, calculate the temperature change during the experiment. And number nine, record the voltage, current, and temperature and time into the table. Number 10, you need to use the equation for energy, which is E equals I, current, T, time, and V voltage, to calculate the energy, and then use this to calculate specific heat capacity. So quite a few steps there. Let's have a go at looking at this in terms of the actual data. So I've given you some, uh, experimental data. This is just a student's work. The ammeter reading or the current reading is 5.323 amps. The voltmeter reading is 11.32 volts. The initial temperature was 12. The final temperature was 41. You will need to separate your work out into stages. That's the best way I've seen students do this in the past. It's a lot clearer for the examiner to see. So I'll run through that with you in a moment. The other thing you need to be aware of is the actual equations you need to know. So if you just look at the current data you're given, there's no data for energy. You actually have to work that out. And to do that, you need to use the equation E equals QV, or charge times V, and Q equals I times T. You don't have anything for Q. So you actually have to utilize those two equations to actually get an answer for Q. So Q is equal to I, which is current, which we have. We've got an ammeter reading. And T, well, that's time. We do have a times reading. So we can put this into an equation that actually now reads E equals I T V. Now that E, that energy, can then be used and substituted into the specific heat capacity equation. So this is where a lot of students find this quite tricky because they've got to do multiple steps. Let's go through it together and let's understand. So first step, change in temperature. Calculate that. 41 final temperature minus the initial temperature of 12. That's 29 degrees difference. We then want to calculate the time. Well, we know this took 10 minutes. So we want time in seconds. So what we do, every minute has 60 seconds. We do 10 times 60, and that gives us 600 seconds. We then need to calculate the change in thermal energy. And like I said, we don't have an energy, so we have to work it out. So we have to use the ammeter reading, or I, which is 5.23, and we're timesing that by the time, which we've just calculated, of 600. And then we times that by the voltmeter reading, which is 11.32. Bear in mind, by the way, if any of you want more help and support with electricity, I know that's quite a tricky topic some people find. Don't worry about it. I will have a video on my channel. If you want more content, feel free to comment below and let me know specifically. So now we've done step three. We've calculated the energy. We've got that in joules, an answer of 35,522 0.61. Okay. We then want to calculate specific heat capacity. So we've written out our equation, which is C equals change in E, or change in energy, divided by the mass times the change in temperature. So if we pop our numbers in, we've got 35,522.16 divided by 1 kilogram, or 1 times 29. And again, I've used brackets just so when you write this into your calculator, the actual calculator reads it in a literal sense. You get an answer of 1,225 joules per kilogram degrees Celsius, and I've underlined it. If you did find that helpful, feel free to comment below. Feel free to comment and subscribe as well. Share, like this video with, and if you did want any more help with your GCSEs, feel free to follow me on my channel. You can subscribe, share this with your friends. Also, I have videos and content on my TikTok at the GCSE Science Teacher, and other resources on my Instagram, also at the GCSE Science Teacher. Thank you so much for watching. I have been the GCSE Science Teacher, and you have been curious. Until next time, take care. Bye.